Hello, welcome to my YouTube channel. Have you encountered these questions in your SAT practice? In this video, I'll be showing you a technique that is going to help you solve these questions in less than 20 seconds. This technique is called substitution or back solving. Come with me as we speed through real SAT questions that you're likely to encounter on test day. So the first question we have: which of the following equations is the most appropriate linear model for the graph shown in the scattered plot? So you only need two things to solve this question. First, you need to understand the nature of slopes, and you need to do a little substitution. So from this graph, from this scattered plot, you can see that this scattered plot has a negative slope. So options C and D are automatically out. So if you substitute a point, you should get a positive value. So option A would give you a more negative answer. So option B is clearly your answer. So you can get your answer without necessarily having to solve anything. Okay, the second question, um, we have this graph. You want us to find the equation that represents this relationship. So two things you have to do here. First is to substitute the intercept. Okay, so we can substitute the intercept for a company A, which is 60. So if you substitute, and this is the x-axis, so if you substitute 60 for x, which one would give you 0 for y? Okay, so substitute 60 for x, and we're looking for 0 for y. So if you substitute 60 here, you're going to get 480. So option B is the correct answer. Okay, the next question. We want to find which equation matches this table, right? So you can see here that these are the values of x, and these are the values of y. So you can see that the values of y are in increasing order. So we have a positive slope. After all, the options all have positive slopes. But if we check for the first option, which is 5, we should get 16. This cannot give you 16, right? So it's out. If you check for 10, it should give you 21. So if you put 10 here, again, you get 33. If you put 10 here, you're going to get something more than 40. So option B is the correct answer. The next question, we want to find which graph matches this equation. So two things you need to do here. X plus 3 is a factor, x minus k is a factor. What this means is if you substitute x equal to -3, you should get 0 for the function. So where do we have the function value being 0 when x is -3? So based on that, you can see that this is out because this is -2, not -3. This is also out. Now, from this graph, you can also see that by the time you expand this, you're going to have minus 3k as the constant, all right? Which means our y-intercept is going to be a negative constant. So this gives us a positive y-intercept, so it's out. So your answer is option D. The next question, we have this equation. They want us to match the correct table. So now, this x plus 6, x plus 5, x minus 4 are all factors of this polynomial, which means if we substitute x equal to -6, x equal to -5, and x equal to 4, we should get 0. But the question is not asking us for f of x. The question is asking us for f of x minus 3. So what that means, if we substitute -6, -5, and 4, instead of getting zeros, we should get 0 minus 3, which is -3. And option B is the only option that captures that. All right. If you've found this video interesting so far, be sure to click on the like button and also subscribe to this channel for more content like this. Now, next question. Here we're given a graph, and this graph is a graph of f of x plus 14. So this is not the actual graph of f of x. This is f of x plus 14 after shifting has occurred. So they want us to find the original graph, which is the graph of f of x. Now, after shifting has occurred, we have that the intercept of y is 2. So if we're taking it back, and this shifting that occurred is 14 plus 14, which means the graph was moved 14 units up, right? So if we want to find the original graph, we need to move it 14 units down. So by the time you subtract 14 from this current intercept, which is 2, you're going to end up at negative 12. And option A is the only option that has intercept of negative 12. Now, next question, we have the scattered plot. It says which of the following equations represent the best line of fit shown? So the trick to solving this question quickly is to find a point that is where the line crosses, passes through the cross line exactly. So you have multiple points like that. You have one. So these are the 2 points that are very precise. This is very close, but not exactly precise. So you can use any of these points to test your options to substitute and find out which one works. Meanwhile, you can easily do this by understanding the nature of lines. So this line has a positive slope. So you can see that option D and option B are automatically out, right? Then let's substitute one of our points. So we'll check which one gives us the correct answer. So substitute 3, we expect to get 8. So if you substitute 3 into this option A, you are going to get something close to 8, as against option C, where the function value is reducing by 2.8. Our next question, we have a table. I want to find the equation that matches this table. So the first thing you do is substitute 0. So if you substitute 0, you should get 29. So option B and option D are automatically out. Now, if you substitute 1, you should get 32. So if you do that, you see that option A is the correct answer. Next question. The scatter plot shows this relationship. We want to find the equation that matches the scatter plot. So one thing you need to do is to understand the nature of your graphs. Okay, very important concept. Understand the nature of your graphs. So this graph has a negative slope. So any equation that has a positive slope is automatically out of the answer choices we have. So we have option B and D left now. So you can substitute a point that is exactly at the crosshair or approximate. So this is one of the points. So when x is 0, y should give us 10. So when x is 0, y should give us 10. Only option D matches that. So option D is our correct answer. Now, write an equation for the graph shown. So here you have to play with your intercept. So when x is 0, y is negative 8. Meanwhile, this line has a negative slope. So any option that has a positive slope is automatically out, right? Now, when x is 0, y is negative 8. So if we test that, both equations pass. Now, when y is 0, x is minus 8. So this is the only option that satisfies that particular condition. Now, our next question, which table gives three values of x and their corresponding values of h of x for the given function? So basically, you're substituting into the functions to get the correct table. So when you substitute 1, you get negative 2. So option A is out and option C is out. When you substitute 2, you should get 1. Both option B and D qualify for that. When you substitute 3, you should get 6. So only option B qualifies for that. So option B is the correct answer. Now, our next question, we want to find a graph that matches this function. So take note, the function you've been given is 2 raised to power x plus 1. But what they're asking you, the graph they're asking you for is a graph of negative f of x. So we need a graph that is negative of that. Okay, so let's start with 0 because that is where we have the y-intercept. So if you substitute 0, you're going to have 2 raised to power 0. So f of x is equal to 2 raised to power 0 plus 1, which is 1 plus 1, which is 2. But remember that we want to find negative. So what we're looking for is a graph where the y-intercept is negative 2. So in this case, this is the only graph where the y-intercept is negative 2. So option C is the correct answer. Now, which of the following is the graph of the equation y equal to 2x minus 5? So first of all, you have to check the nature of the graph. This equation has a positive slope. So this option B is out because it has a negative slope. And when you substitute 0 for x, the y-intercept is negative 5. So let's find um, the graph that has positive slope and the y-intercept negative 5. And that's option D. So that is our correct answer. Now, in the next question, we have a scatter plot. I want to find the equation that matches this scatter plot. So let's find exact point or approximately exact point for this line of best fit. So we can make use of 16, not really exact. Okay, we make use of 20 for ease of substitution because of the zero here. So let's make use of 20. So we should have a value between 700 and 800, probably around 750, right? So let's substitute 20 here. Substitute 20 here, you would not get something between 700 and 800. Substitute 20 here, you're going to get 600 and something, not 700 and something. If you substitute 20 here, you're going to get about 900 and something. So this is out. So this is going to be our answer. And of course, substitute 20, you're going to get 660 plus 84, which is 700 and um, 44, right? Which is close to 750. So that is our correct answer. Now, in this graph, they want us to, based on the condition they've given us in the question, the range of the polynomial function f is set of real numbers less than or equal to 4 if the zeros of the function are minus 3 and 1, which of the following could be the graph of y equals f of x. So two things you need to do here. You need to check your solutions and you need to check your range. So the range is less than or equal to minus 4. It means the maximum of this function should be 4, right? It should not exceed 4. So with this graph, the range is going to exceed 4. With this graph, the range is going to exceed 4. So C and D are out. Now let's check A and B. We're told that the range should not be more than 4. So the maximum for both graphs are is 4, right? Now we need to check the solutions, the zeros of the function, minus 3 and 1. So this is minus 3 and 1. This is minus 1 and 3. So you need to be very careful. SAT has set a trap here. They expect you to switch the signs, right? So this is our correct option, option A. Now, in this question, we've been given year and population. The table above shows the population of Greenleaf, Idaho, for the years 2010. If the relationship between population and year is linear, which are the following functions P models the population of Greenleaf T years after 2000. So one thing you need to take note of here is that the population is decreasing. So we're looking for an equation where the slope is negative. All right, we're looking for an equation where the slope is negative. So here, if we substitute 2000, we will not get it. So option A is out. If we substitute 2000, we will not get the population. So option B is out. Now, remember we need a slope that has a negative, we need an equation that has a negative slope. So from here, I can just pick option D because option C has a positive slope. And of course, if you substitute, you would actually get the correct answer. So this is it on how to solve questions where you are matching equations to graph or matching graphs to equations. You simply have to use substitution or back solving. So if you've not liked this video, go ahead and do that. You can also leave a comment in the comment section. Tell me which question you found the most interesting and also drop your target SAT score. And if you've not subscribed to this channel, go ahead and do that so that you have more content come your way to prepare you for your SAT. See you in the next video.